So in this video we want to briefly introduce the three-dimensional coordinate system. And so to get at this, I kind of would like to start with a line. I think this helps us to think about it a little bit and to abstract some of these ideas into higher dimensional space. But when we have a line and establish the zero mark on it, so let's say that's 0, what we have is a point, which is a zero-dimensional object. A point is a zero-dimensional object. And that point, when we establish that 0, breaks the line into two separate lines. One that goes to negative infinity, one that goes to positive infinity. So we can think of the point 0 on the line as breaking the line into two distinct one-dimensional objects. So a zero-dimensional object breaking a one-dimensional object into two distinct one-dimensional objects. When we go ahead and add that extra axis or real number line to create the Cartesian plane, we can kind of think about what's going on. We're kind of analoging up from this example, and what's happening is we get two 1D objects. Lines are one-dimensional, they have length, so we wind up with two one-dimensional objects, and in other words two lines, and they break two-dimensional space. So we're breaking a two-dimensional space, the Cartesian plane, into four distinct regions, because each line breaks two-dimensional space into two pieces. So we get 2 times 2 is 4, and we usually call these four quadrants. Quadrants 1, 2, 3, 4. So here we get a one-dimensional space, a line, being broken by a zero-dimensional space into two one-dimensional spaces. Here we have two one-dimensional spaces, two lines, breaking two-dimensional space into 1, 2, 3, 4 two-dimensional spaces. So all we're going to do when we do a three-dimensional coordinate system is add an axis perpendicular to the xy plane. All we do is add an axis, the z-axis, perpendicular to the xy plane. And what we wind up with is three planes. We wind up with, here we have a three-dimensional space now. We're in three-dimensional space. We have x, y, and z dimension, which establishes 1, 2, 3 planes, which break, and planes are two-dimensional objects. We wind up with three two-dimensional objects. Each two-dimensional object breaks three-dimensional space into two pieces. So we wind up with 2 times 2 times 2 is 8 distinct octants, 4 in the upper plane and then 4 down in the lower plane below the x. This is the xy plane right here. So that's all we do to establish a three-dimensional space. We add in that extra axis orthogonal to the other two axes, and those each line, each axis works with another. Here's the YZ plane right here, formed by the YZ axes. The XZ plane right here, formed by the X and Z axes, and the XY plane formed by the XY axes. So we get three two-dimensional objects breaking three-dimensional space up into 8 distinct three-dimensional spaces. And I wanted to take this approach because even though we're going to be focused on three-dimensional space right now, the question you should ask yourself is, how would I create a four-dimensional space? And we would do that by adding another axis perpendicular to or orthogonal to each of the existing axes. And then the question you could ask yourself is, what happens when I do that? How many regions does that break four-dimensional space into? And what's going to wind up happening is you're going to get, you have a fourth axis, so now you have 1, 2, 3, 4. You're going to have 4 hyperplanes breaking, or 4 three-dimensional planes, so 4 hyperplanes breaking four-dimensional space into 2 times 2 times 2 times 2 is 16 regions. 16, in fact, four-dimensional regions. So we'll get 4 3-dimensional objects, breaking 4-dimensional space into 16 4-dimensional regions. And then the extension question would be, and you should take some time to think about this and maybe do a little bit of just reading about hyperspace, hyperplanes, that type of thing. But what would happen if we wanted to make an n-dimensional space? We would need to have n axes, and each axis would form an n-1 dimensional hyperplane. And here we had this the one-dimensional space. We broke it. If you look at this, how many regions, we had a 0-dimensional space that broke it into 2 regions, so that's 2 to the first. Here we get 2 squared is 4 quadrants. Here we get 2 cubed is 8 octants. 4-dimensional space, you would get 2 to the 14th is 16 4-dimensional regions. So in n-dimensional space, we would wind up with 2 to the nth regions that were separated by these n-1 dimensional, maybe we could call them hyperplanes. So something fun to think about. But we're going to be working here in mesolial 3-dimensional world, and in the next video we'll look at hand graphing coordinates into that 3-dimensional coordinate system.